My name is Susanne Klein. I'm an associate professor at the Center for Fine Print Research and the EPSRC Manufacturing Fellow. The EPSRC is the Engineering and Physical Science Research Council. I'm the first woman who has got this fellowship. The fellowship is meant to bring industrial expertise into an academic environment. It's also the first time that this has been given to an arts faculty. Before, it has always been given to engineering or physical science faculties. And that shows, in a certain sense, what a good reputation the Center for Fine Print Research has, that they are indeed world leading. So I have worked before for about 20 years in industry. I came to the UK from Germany in 1995. Was first a Royal Society Research Associate at the University of Bristol. And then I started at Hewlett-Packard Labs in Bristol as well. I'm a physicist by training. I worked mostly in materials. So first in new materials for display applications, then in new materials for 3D printing, especially silica classes, and then a little bit of dabbling in optical cryptography. I have a very special project which is about photographic methods from the 19th century which should be resurrected and translated in 21st century disruptive technology. So one is a photographic reproduction method called Woodberry type, and the other is a direct photographic process called Lippmann Photography. Woodberry type is interesting because it was the first commercially successful photographic reproduction method, but it got forgotten because it couldn't combine text and pictures at the same time. So it became obsolete because it was too costly, and it was replaced by half-toning. Basically, all the present-day pictures are half-toned, whether they are on your telephone, on your computer, or in print. So here, these are some examples of original Woodberry types. The best Woodberry types are from the book Men of Mark. And of course, they're all men, but I like the women better. But there are continuous tone. That means today, most reproduction, whether it's on your screen or on any printed material, are dots. It's called half-toning. But here it's not. It's generated by a relief. So the different darknesses you can see are generated by having different thicknesses of gelatin with soot basically in it. So my task is to develop inks which can then produce a full color print. And here's one of the first attempts. It's not yet right, but we are getting there. And then to translate it into a method which can be inkjet printed. So take it away from the original impact printing, which is simply a plate and then you put the paper on and you transfer the gelatin ink onto the paper into a method which is inkjetted. That means the ink goes directly on the paper without a plate, and that gives you freedom of size, freedom of topic, freedom of color. So the other method is Lippmann photography. Lippmann photography is a direct positive photographic process. So you have a glass plate with your photographic emulsion. You have a camera. You insert this glass plate in the camera, and behind your glass plate is a mirror. So when the light comes through the camera lens onto your photographic plate, it's reflected by the mirror and it forms standing waves with the incoming light. Where the nodes are, nothing happens, but where the wave oscillates, your silver halide in the photographic emulsion is developed into silver and forms semi-transparent mirrors. So when you then develop your picture and you fix your picture, you have now a succession of semi-transparent mirrors in your emulsion. When you shine white light onto this plate, only the colors which generated the layers of semi-transparent mirrors will be reflected. And this, you have the biggest color gamut you can imagine because it's not restricted by any dye stuff. So my task will be to transform it from a direct positive photographic process into a printable process. Because Woodberry is a relief and Lippmann is a layered method that can be combined, but it has extremely high demands on the inkjet printings. Future research will take that basically into modern industrial applications, and there is more to come.